All right, so here's your new homework assignment. This is homework number 9. All right, and consider the speed of light in different materials. Okay, so let's consider that. And so, what is the speed of light in water? All right, so basically, you know, that's no big deal. In fact, we just did a problem like that. So that's I just kind of wanted to go through these and see, make sure we're covering there. Suppose the speed of light is this. See, I don't like that. All right, so I would ask you, what's the frequency? Calculate the index of refraction of the medium. Well, that's pretty simple. And then based on the table, identify what is the most likely substance. You know, nothing to that. You know, well, let's. You know, I'm sitting there saying nothing to that, but again, if we want to know the medium, N, all right, N is equal to C over V. They gave us V of that medium, all right, and we know those two numbers. So you just divide those two and you get what N is. That's not too bad. I wanted something a little more. Here we go. A beam of light traveling through a liquid if index refraction is incident at an angle, okay, of 41 with respect to the normal to the surface. It passes into the second median refraction angle with respect to the normal. All right, so there we go. So it's coming in at 45, shoots back up at 69. So it looks like N2 is going to be less than N1. Write an expression. Okay, so this is one of those problems where you write an expression for the index of refraction of the second material, which might be kind of tricky to do, but let's just go ahead and see if we can get that done. So that might be a good place to kind of get started with this. What am I working on? Here we go. Let me go back and see. See, some things don't change. N1 is equal to 1.26. No units. Theta 1 is equal to 45 degrees. Theta 2, notice we're using theta, so we don't need all those phi's and stuff. Is equal to 69.5 degrees. And we know that Snell's law says this. Here's what Snell's law says. Snell's law says N1 sine theta 1 is equal to N2 sine theta 2. Well, it looks like this looks pretty simple because they just want an expression for N2. That's it. Oh, how hard is that? But let's make sure that we do this right. Now, remember, this is a machine. So N2, normally we just go N1 sine theta 1 over sine theta 2. Okay. Piece of cake, right? We got that. But I think we better put parentheses around these. Otherwise, should be okay, even without parentheses. But let's just go ahead and put the parentheses. Yeah, they're kind of encouraging us too. And we'll go N1 sine theta 1, close parentheses, divided by sine theta 2. You see sine theta 2? Okay, that wasn't hard. Then numerically, what is the light's velocity? What is the light's velocity in meters per second? What is the light's velocity in medium 2 in meters per second? Oh, well, this is kind of interesting. Well, since we know the indexes of refraction, then we can find those. So that's not hard. All right, here we go. Internal reflection. So we looked at some problems, and we'll stop here, and then we'll start with internal reflection.